Hi everyone. So in these next couple of videos, I'm going to talk through a few more complicated concepts that you can use in pandas that will make writing these complex rules easier. Mainly focused around grouping, which is what this video is going to be about, and merging, which is what the next video is going to be about. Grouping is about grouping similar classes of data and doing operations on those groups. It's a helpful tool for things like when you need to count the total number of episodes or like figure out specific things on like a child level from say the episodes data. And then merging is more about wanting to combine data from more than one table. So maybe combining the episodes data with the header data, and making those joins and how to think about still returning the values that you want from that. So you're probably thinking, why have I got Excel open at the moment? So what I wanted to do was for this video about grouping, I wanted to initially show the idea, because it's very similar in Excel to the idea of making a pivot table. So here's some synthetic episodes data, right? So we've got some kind of child IDs. We've got various episodes that have happened here, and maybe you want to find out the number of episodes that each child's had. So you can do that, and hopefully this will be familiar to most of you, which is why I'm starting with this. If you're not really a big Excel person, you can almost skip this little start of the video. The idea is that you say you want each row to be a unique child ID, and then you want to count the number of each rows. So I mean, you might as well just count the number of children here. So if I change this to the count, this tells me child 32 had 1 row, 982 had 3 rows. 9490 had 4 rows. I mean, we can even check this. If we look for 566910, this first one, in here, you can see it shows up as having 2. And this operation where we sort of grouped by the child IDs and then counted the number of child IDs, this is exactly the same sort of thing that we're going to be doing in code. So if I open up, here's one I made earlier, a replit that has access to this data. So I've got our sort of main Python file, and I've uploaded a couple of these synthetic CSV files. And again, if you want to follow this along, that's fine, but make sure that you use the synthetic data. Don't upload your real data to replit, because that'll be breaking any sort of information governance procedures that you may have. But in this case, so if I put in the episodes data, like so. I'll just print this out to remind everyone that it's the same bit of data here. And you can see again we've got this group here. So what I want to look at doing then is let's try and replicate that same thing. So if we do .group by child, this in itself just returns I think it's called a grouper or a grouped object. And if I try and print this out, it doesn't really make sense. So what we'll get out of this will just be a pandas generic group by object. So this is because all you've done here is you've indicated that you want to group by this, but you haven't told it what it is you actually want to do. So I'll just I'll reprint this episode table to kind of remind ourselves what we're working with here. So maybe what we want to do here is we want to count the number of episodes. So what we can do is we can then select the column that we want. So let's say like the date the episode commenced, and then apply an operation like .count. So what this will then give us is that exact same pivot table. So this is now the number of children. So you can see this has a shorter length 2,100 rather than length 5,000 of the overall episodes. And we've got this number that will be the count of the decom in every child, and that broadly speaking is how you do these groupings. So count is not the only operation that you can do on these data frames. You can also do numeric operations. I mean, they don't make sense for this kind of data, but if you have say numeric data, you could type .mean or .sum, and you would still get this kind of like aggregate output. For our purposes, we don't care so much about the aggregation. We might care more about kind of how we then link this back. Because I mean, say if you imagine you had a rule which said that no child should have more than 5 episodes. Unfortunately, you know that this isn't true. So having the data in this form. So if I run this again, just to remind you. So having the data in this count form is all well and good, but you still got to kind of link that back to the episodes table and be able to output the index numbers where this error is firing. So a way that you can do that in the grouping framework is to do what's called a transform. So if instead you call transform with a text string describing this operation, so count or sum, and you can get a full list of the supported operations in the Pandas manual. I need another bracket there. What you'll get instead is this will return a series with the value that's the same size as the output data, or the input data, but the value is the count grouped by child. So what I can do here is I can then say, right, we'll do episodes total num episodes equals this. Then if I print this again, you can see that, yeah, that column's now been added to the main data. So then if I wanted to get the index where total number of episodes is, greater than 3, then I could just do episodes, total number of episodes, greater than 3, dot index. And you can see here, I've got on about 1,200 children, which all have episodes greater than 3. Presumably if I put this to about 6 or something, we should start to get a really small number. Yeah, so now you see we've only got about 30 or 40 of the 2,000. So that's how you can sort of use this in theory. But I thought rather than sort of trying to guess at the use cases, I figured I'd pick out a few errors, sort of talk through the way that I'd approach the sort of grouping part of them, and maybe give some examples about how that would work. So here's just some I've picked out. These are all advanced rules. So for this one, this says that the first episode must be S. So this concept of the reason for new episode must be S for a new episode of Care, or for a new episode ever. Sorry, in this case. So the reason that this is actually a grouping question is because you need to be able to group by children to get their list of episodes, which makes sense to be able to actually figure out which episode is their first episode. You can't do that just with the Boolean masks. So the way that you'd approach this here would be, if you go back to the grouping here. So let's say that I want to find out when the first episode is. There's actually already a function in Pandas for doing that piece of work. So if I go back to my episodes dot group by child here, and I think, right, okay, what I want is, so the first episode is going to be the first episode where the date commenced. So yeah, the first episode is going to be the episode which has the minimal date of commencing. So if I have a look at what that looks like, what you'll see here is that for each child, I've now got a list of the dates of their minimal episode. However, this is helpful, and there'd be ways to sort of then look, okay, for each child, get the episode that has this date. That would work. But there's actually an even simpler way to do it. So there's, as well as having min and max, there's also built-in functions idx min and idx max. And what this says is, rather than returning the so perhaps it would be helpful if I actually print both of these. So rather than just returning the minimum, what this will actually return is why is that failing? You see, because I need to convert this into a date time. So, and this will be the same thing as if I was writing a rule. So I'll just write that quickly now. And I've made a mistake there. But fingers crossed. Now it's working, and now it makes sense. I think the min works anyway because min is defined for strings, but this other operation doesn't work as well. So what you can see here is, now that we're printing this out, so this is saying that the minimum date for child 32 is 2017-02-12, but this actually is giving me the index where that minimum occurs in the original data frame. And this is super useful because basically, so I mean, say right here at the start, we've got this, so for child 32, the index is 4801. So if I do episodes.lock 4801 and print that out, what you'll see is that that's actually, don't know what that's, there you go. 2017-02-12 is actually the date commenced of the episode. So this list of indexes is actually the lists of the first episode that these children have. So then with that information, it's quite easy to be, so my sort of mask would then be episodes. So if I call this, let's say, index of first episode, or episodes I'll call it, then I can do episodes where the index is in that index of first episodes, and the reason must be S, so that'll be episodes R&E equals S. And and of course I need to actually print this out, but it hasn't crashed, which is a good start. And yeah, you can see here we've got 260 rows where that's true. And yeah, I mean, obviously we're not perfectly for the rule here, so I guess these are actually all the episodes where it's right. So actually, instead of being not equal, and that shows all the episodes where it's not right, which in the synthetic data is loads because it's I think it just uses a random code here. But yeah, so that's how you'd use group by to do things like get the index of first or the index of last episodes. So we can look at a few of the other rules here that I pulled out. So we've got a rule like this, which says that the DCOM of the current episode should be greater than or equal to the so that's the date commenced must be greater than or equal to the date ceased of the previous episodes. So for this one, I won't go into all the details, but again, for this, you're going to want to try and get the try and add a column that has, for a given row, what the DCOM of the last episode was. So a way that you might start going about that is you can do something like a group by shift operation. So if I sort of print out the episodes here, sorry, I think I've lost my printing. There we go. Right. So what you're looking at here is you've got your episodes table here at the top. And then what I've done here is I've said, can you actually shift that DCOM column forward by one index? So you can see here at the top the first child. And yeah, sorry for the kind of poor formatting of this, but the first child, 566910, has two episodes, 2016-02-15 and 2017-08-14. However, now we're actually getting two new indices, not a time, and then 2016-02-15. So this shift operator, it's not an aggregating one like it was with the count or the IDX min or the max. This is the transforming operator. So this will return something that's the same length, 5050, as the original data frame. So then in order to get the DCOM last episode, I can just assign it to this, and then my episode should have a new column showing me this DCOM last. And you can see it's not a time if there is no last episode, or here it is a time. In fact, probably it's easier if I just sort of get just those 3 columns out, because I appreciate this is a bit difficult to read if you're not familiar with looking at this. What was it? Decom last episode. And if I run that, there you go. You see, so you can see. So for example, children that only have 1 episode, they just get not a time or not a time. Children that have more than 1, you'll actually get the previous episode there as well. So this is sort of a start for how you might start to get access to that last episode, and obviously from this you can then use the original simple techniques to build out your work. Yeah, so then we can talk about this rule. For this rule, what this is saying is that if for any episode in this current collection year, if the legal status is not V3 or V4, and the sex of the child is 2, the mother must be provided. So this rule, this is a more complex rule that requires multiple bits of joining. So this requires joining up the episodes, where legal status is, with the header file that has the sex and mother. So I won't go into all the different parts of this, but I'll talk about how you might find out for a given child if any episode in the current collection year has this legal status not V3 or V4. So again, so if we say sort of like, so the code list is going to be V3 or V4, right? And you're going to want to pull out probably through. So to do this grouping, you want to find out if any of the episodes have that code. So, and that's in the legal status column. So if I look at this Boolean mask, right? So episodes legal status is in code list. I can call this episodes has code, something like that, right? Then let's think about doing that grouping again. So group by child. And then what I want to do is I want to take has code, and then we can look at any, I believe. Does that work? Yeah. So what we've done here is we've grouped by child. We define the sort of like helper column, which tells us for individual children whether or not they have this code for an individual episode. And then here we can check by grouping whether any child in that group has an episode. So we can see that 32 has no episodes, 1243 has at least 1. And again, if you want to get this, I mean, this is again in this kind of aggregate form where it's only sort of one row per child. But you could also do dot transform any, and you should be able to get the same thing as a column that you could then use as part of a larger Boolean mask to build out that rule. And the final rule that I'm going to talk about today, just another fairly straightforward one here. So this is, you have to check and see that you don't have more than 2 episodes with placement code T3, as in 2, which would be 2 temporary placements. So in order to do this, you would kind of use similar things to what we've been doing already. So you come back here, you'd have a look at the placement code. So it should be episodes. I think it's either PL or I think it might actually be place in our data. So in this case, I'll say like is T3. Get rid of this code list and all this stuff. And I'll say episodes place equals T3. And then what we can do is do an is T3 dot sum. And you can see so this is checked that the place code is equal to T3, and then per child we get the total number for that child that has where the place code is T3. Again, in this case, you still probably would rather use this transform version get it into the right form. There will be cases where you want to use the group by aggregate version, for example, the IDX_min, IDX_max functions. But in a lot of cases, you are going to want to go for this transform. And then summing, so because like true and false, which is what this is viewed the same as 0 and 1, you can use this trick where if you sum true plus true plus true, you'll get 3, or true plus false, you'll get 1. And relying on that trick, you then see, right, okay, so this is now in row form rather than the kind of sorted child ID form, and there are some children that do have 2 T3 placements. Again, this is synthetic data, so it like might not match reality, but then you could use the outputs of this in order to build that last rule. I'll quickly mention this other rule. So this is again probably a more complex rule again. Lots of different requirements here. You need to group some adoption tables, some episode tables, and look at some date of births, deal with time series. This is the sort of thing that's going to be one of the harder rules that we have to come up with. But this specific concept here, so the total days of previous episodes, where legal status is not V3 or V4. So I think if we ignore that part now and just focus on the total episode days and how you might go about calculating that. So again, in this case, you're just going back to using similarly kind of a transform sum, but you need to actually calculate these days first. So if I do the same date-time conversion for the date ceased here, then what we can build the length of the episode by just doing dec minus episodes decom, like this. And again, we can just take a .tt.days, which will give us that overall length. And then what we can do here is if I just sort of take that helper column that we've made, which will now have a numeric value in it, we can then take the sum to get the average, or to get the total number of episode days. Oh, there's an error there. Well, so what I'll do for illustration purposes for now is I'll just remove that date format. So I mean, the actual numbers here might be slightly wrong. I could dig into that another time, but you can see here that now you do get what looks like reasonable total episode lengths for these, and you could also look at things like mean for getting the average episode length, which can be helpful for things like analytics, and all this kind of stuff. So hopefully that's a bit of a crash course on the few different ways you can maybe use grouping with the episodes to produce different values that you might need to build the more complex rules. And also hopefully kind of a hint on like how you might use it for other analysis. There may be other things you need to look at rather than just the episodes table for grouping these, but I think that makes up about 95% of the rules. Hopefully that makes sense. I'm looking forward to going through merging.